Okay, generating PDFs is kind of sort of something that doesn't work sometimes. Anyways, Patrick Feldström, I'm Technical Director and Head of Security at NetNode, and going to talk with you a little bit about the difference between redundancy and diversity. Because this is something that comes really, really close to our heart. Because when you want to, this just doesn't work. Should we do something else? Who has the computer? I can send a link to Google Drive or something. Who is running the computer? Or I'll just talk anyways. This just takes time. Okay, we get it. Anyways. So a lot of people talk about redundancy, and redundancy can solve a lot of problems by having multiple entries, multiple boxes, multiple anything. But sometimes these redundant entities actually are dependent on some kind of single point of failure. They're connected to each other. They have the same control plane. They might have sort of the same kind of fiber, maybe the same vendor, maybe the same whatever, same something. And that is something that you have to take into account when you're doing your risk analysis and when you look at what kind of threats you're nervous about. So on the scale between something that is completely redundant or what I would call diverse, that means that you have absolutely nothing that is in common between multiple entities. So from the complete independent entities to something that is just in one box, if you understand, is a grayscale. And this is where you can sort of debate what redundancy and what diversity do you really need. And that, of course, depends on what your threats are. You might, for example, like to some degree, as you will see in my example, when I will talk about how we at NetNode are producing time and frequency at the various diverse nodes, as I call it. But on the other hand, we use a lot of equipment from the same vendor at those locations. And that is a calculation of risk that we have taken, and I will explain a little bit more about that. So when talking about redundancy, sorry, let me take a step back. If people just talk about redundancy, to me that is not really enough because as not until people use the word diversity, that is the time when I understand that people are starting to think about how much diversity do you really need. So geographical diversity is, of course, something that is quite good. It might be the case that you have flooding, you might have fires like we had in Germany the other year. It might also be the case that, as in France, Free released these pictures. A lot of people that I've been discussing this with have said it's a little bit weird. They talk about the fiber being cut, but you cannot really see any fiber here. There are some other pictures where you actually do see some fibers, but you have these kind of cuts that happens now and then. No one really knows what actually happened. You might have fires, you might have other kind of natural catastrophes that impacts some of your physical infrastructure. So geographical diversity is of course one thing that is pretty good, but then you might want to have diversity in other layers in the value chain as well. So this is neither Swedish nor Danish. I think these slides have a hangover. Oh, this works. So you have the fiber. Thank you very much. There were some problems with embedding the fonts in the PDF, I understand. So anyways, so we had the fire down in OVH, where some customers actually had multiple racks in different locations, but in the same building, and the fire was big enough so that actually bad things happened. Of course, just because sometimes everything just goes bad, like at OVH. Maybe it was a risk that was acceptable. That is also something to remember, that when you have someone that has some downtime time, it might be the case that the risk they calculated gave them the result, ended up in the result that they saw that risk is acceptable. And instead, it is a risk that is known, and if you have a known risk, then you probably also have a process for how to do restoration. So risk appetite means that you probably have a known risk that you're able to handle if it is the case that you have a crash. or if something happens. So if we look at sites, which is what we do at NetNode, we have a site here in Copenhagen, we think it's really important that our sites are diverse, so that the sites actually are independent of each other. Where also the services at the various sites that we have are diverse. But of course we have made some choices of having some similar components of the various sites, like the way we build the control plane. We need to be able to, like you saw in the previous presentation, we need to be able to understand what's happening. There are some single points of failure there. It's also the case that we use a similar hardware, as you will see when we talk about time and frequency. There is also risks we take, but we have also tried to mitigate that. So the way we look at things at NetNode is that we have diverse nodes. And these are the diverse nodes we have in Stockholm, Gothenburg, Copenhagen, Malmö, Oslo, Helsinki, Sundsvall, Gävle, and Luleå. Each one of these are independent of each other. You might think that, well, wait a second, but you at NetNode, you sell various services where we can connect at one of these nodes and then connect to another one. So obviously they are connected to each other. Yes, but that is as an additional service with transmission that you can get from us independent from how we build the nodes. But the site in Copenhagen, Malmö, obviously consists of multiple locations which are connected to each other. Yes, but we call that all of them being part of a node. So the various locations where you can connect, yes, they are to some degree diverse, but they are absolutely not as diverse as the various locations we have, for example, Stockholm and Copenhagen, Malmö. So Copenhagen, to some degree, the sites in Copenhagen are sort of separated from the ones in Malmö, but they're connected to each other in a completely different way from, for example, Malmö and Stockholm. So we have, at the moment, we have 10 locations in Stockholm, 2 in Gothenburg, 4 in Copenhagen, Malmö, 4 in Oslo, 3 in Helsinki, 3 in Sundsvall, Gävle, and 1 in Luleå. So these are sort of 2 layers of diversity that we have implemented in our network. So, and then for each service that we are locating at each one of these nodes, we also sort of do a risk analysis. And how have we done? And the question now is how we're done with time and frequency. Time and frequency we have at 2 locations in Stockholm, Gothenburg, Malmö, Sundsvall, and Luleå. And each one of them are completely independent of each other. And this is one of the reasons why we do not have an UTC NetNode timescale. We do have a timescale at each one of these nodes. And we are steering that timescale towards the Swedish UTC SP. And one thing that we're working on is to calculate an average of these and steer towards our own average and then steer that towards UTC. But at the moment, we have one timescale at each one of these nodes. And let me talk about how that works. This is one way of being independent. So to be able to explain that, I need to explain first what is a clock and what is frequency. Okay. Some people are laughing. I was laughing as well when I was thinking what a clock was until I started to understand what a clock was. And then I never came back. A clock consists of 2 things. Something that ticks and something that counts the ticks. Okay? 2 completely different things. When you think about it that way, it's not so hard to think about counting the ticks. We just need to agree on what number we should start counting at. That might be hard enough, but let's say that we can agree on that. Let's focus on the actual ticking. When we look at the ticking, we want to have both high precision and high correctness. So we want to be up there. So we need to really know what we are doing. And it's a little bit difficult to be precise because of certain physical problems that we need to accept, like the speed of light and gravity and temperature and other kind of things. But if it is the case that we are going to look at frequency and how things are ticking, the first thing we need to agree on is what is the distance in time between 2 ticks. Okay? This is something that we actually agreed on in 1859, and then we have refined that. So at the moment, a unit of time, which normally is called a second, is a certain number of vibrations of a certain isotope of the cesium atom. That definition is, of course, theoretical to start with, which means that you can never generate that exactly. So you need to sort of adjust a little bit on you. You have something that actually vibrates, and then you need to recalculate and adjust that so you can translate it into the official ticks. So now we have a unit of time that we agreed on. But the next thing you want to know is also when this tick is happening. So when we just look at the frequency and ignore the counting, there are two different problems we have. One is the frequency, and the other one is the phase. So we want the ticks to come at equal distance from each other, and that, otherwise we have a frequency error. And then we also want to have the ticks at the same time, and that's a phase error. Okay, if we now want to have two clocks that actually ticks at the same time, we need to steer the clocks to make sure that the ticks have the same frequency and the same phase. And this is something that is a little bit difficult if the propagation time of the signal, which is speed of light, is longer than the precision we want. For example, we have a clock in Stockholm, we have a clock in Malmö that's like 600, 700 kilometers. It takes, the speed of light is 30 centimeters per nanosecond, and we want our clocks to have a phase error that is less than 10 nanoseconds. 10 nanoseconds is the speed of light of 3 meters. Okay, how do we even measure? From here to that clock is better precision. The three clocks in the back of the room can have the speed of light between them is approximately the error that we have in our clocks between Stockholm and Malmö. So we need to look at the propagation time. And of course, if you know the propagation time, then it's easy to deduct that when we do the measurements. But then because of temperature and other kind of things, you might have variation in propagation time, even in fiber, over long distances. Many of you who work with fibers know that much better than me. And another thing that you might have is asymmetry in the propagation time, that the signal takes it takes a different amount of time for the signal to go in one direction from the other. And you might think, well, that might be two fibers that are going different paths and whatnot. So why don't you have the signal in the same fiber? But then you actually do have different propagation time in a fiber depending on the frequency of the light. So yes, for time, we normally do use bidirectional signals in one single strain of fiber, but that frequency difference that we get is enough that we need to compensate for. But bidirectional signals in a fiber is what we normally use. And then, when we have solved this problem, which by the way, we normally do by we know where our receiver of antenna is in Stockholm, we know where it is in Malmö, we know where the satellites for GPS is. We see a signal that comes from the satellite. It says ping, just like in Monty Python. And then the machine that goes bing, and it ends up at the two receivers. And then we can, because we know where the satellite is, we can calculate that triangle and use what is called common view to do the actual adjustment of phase and frequency. So that's basically how it works. So we do get data from some other clock. And then we have our own frequency source. And this is basically how a clock works. You have a frequency source, you do a phase and frequency adjustment, and that produces your time scale at this very clock. And now in these times when we have a lot of disturbance of GPS, a lot of people say, but wait a second, GPS goes away and then, boy, my car will drive into the ditch or whatever, or my clocks will go wrong and blah, blah, blah. The thing is that if it is the case that your frequency source is stable and doesn't change much, that means that you don't have to get data from other clocks as frequently as if your frequency source is bad. So the more stable your frequency source is, the less often you need data from some other clocks. So if it is the case that you're nervous about getting disturbances or jamming of a GPS signal or something because you use GPS receivers, buy a better frequency source. And how good should the frequency source be then? Well, it depends on your appetite on what kind of error of phase error that you can accept ultimately in your application. So what we do is that we use this common view GNSS. We use at the moment GPS, but we are looking at other sources as well, like Galileo. We use cesium frequency source. We do the adjustment, and then we make the time scale at each one of these nodes available with 3 different protocols, NTS, NTP, and PTP. And because these nodes, this is at one node, is independent from each other, this is why the time scale that we get as a result of the phase and frequency adjustment is different at each one of the cities where we do have nodes. And now some of you say, okay, that's cool, but what happens if your frequency source goes poof? Well, because of this, we have redundancy in each one of these nodes. This is not very diverse. There are 2 racks. But on the other hand, we have double equipment of everything. We need to have them close to each other just because of the signal propagation time in the cables. The length of the cables are marked in nanoseconds, so we can adjust. So we buy the cables, send them to a laboratory. We got them measured, we got them back, and we can then adjust the equipment in the propagation delay. So we have 2 different frequency sources that you see at the bottom at each one of the nodes. And then we do have everything else that is doubled. And this is just because we want one node to be as stable as possible. And the double cesium frequency generator we have, what we have seen is that each one of these nodes is stable enough to be within 100 nanoseconds, even if they're isolated in 6 months, the way we have built this. If it was only one rack, it would not be so good, specifically because some hardware go poof now and then. Some power, some PDU or something doesn't want to play. So this is comparison between the Swedish time, UTC-SP, and one of the 2 timescales in Stockholm. And you have the nanosecond. You see that we are within 10 nanoseconds over, this was in March, from 1st of March to 1st of April this year. So after after we have produced a time scale, we do measurements with common view again on the difference between the various time scales and the various nodes. So this is sort of evidence that we actually managed to make this as good as the goal is. So back. So anyway, so why talk about this so much? Let's go back. So the goal here was to try to show you the difference between the redundancy that we have within each one of the nodes of the clock. But then each one of these nodes that we have here is completely independent of each other. So on the lower level, we have what I would call redundancy, but on the higher level, we have diversity, even by having different timescales. And of course, some people might say, oh, why don't you have a net node time, as I said earlier? But no, this is actually much, much better that they are independent of each other. So yes, the time in Stockholm might be more different from time in Copenhagen, but that's it. Thank you.
Thank you, Patrick. Good closing act as ever.
Tom from Cloudflare, thanks for taking the time to answer questions and to do the presentation. With your geographic diversity, is there any plans of having same metro geographic diversity, or is that something that you're not really interested in at this point in time?
Can you repeat that word? If I was thinking in what?
The metropolitan area, so
metropolitan
within
area.
Stockholm or within Gothenburg to have diversity.
Yeah, as I see, we have 2 different nodes in Stockholm which are diverse from each other. That is a request from customers to have 2 nodes in 2 different bunkers which are completely independent of each other. In one of these 2 locations, we actually have a separate node, so there are 2 nodes in one of those locations that you use for testing and upgrades and stuff, just because, as you saw, we have similar equipment from same vendors, so when they're coming with new software, we can sort of load that, and just because we've written our own, we implemented NTS in FPGAs, so we also need to test our own code. But yes, the 2 nodes in Stockholm are completely independent. Regarding Copenhagen, Malmö, yes, there are some interest in Copenhagen in Denmark for us to have a node here as well, and the same thing in Norway, if it is the case. But there are discussions ongoing, and what is also important is, of course, as I just explained, that also the customers of this time understand what they're actually going to use time for, because if it is the case that just like we, just like we use common view as data from other clocks, if our customers in their net node will be up there, right? Which means that also for that kind of more complicated system to get actually some effect, for example, a different node in Copenhagen than Malmö, that implies that the receiver of that service need to understand how to do this, so it lives up to whatever kind of requirements they have. But that is also something that we're working with, for example, the financial and energy sector and stuff to try to do. So yes, we're working on it.
Brilliant, thank you.
Thanks.
Any more questions? If you don't have questions, of course, you can always fill out the surveys, because we've got 3 of them. Yesterday, today, and the whole event.
So when you only
Who are you?
Mikkel from Subspace. Thank you. So when you only have 2 nodes in a location, do you then use GPS to check if any of them is ticking wrong?
Yes. Okay. Each one of these nodes, each one independently of each other in Stockholm, do have independent satellite receivers that are measured, so we can do this common view measurement. It's also the case that we, from one of the nodes in Stockholm and up to Sundsvall, we're also running White Rabbit, which is sort of P2P equivalent, sort of similar protocol over fiber between Stockholm and Sundsvall that we have done measurements for, but that we also know how to run. But the equipment for White Rabbit is not really stable enough for production anymore. So because you need special amplifiers and splitters and frequency, blah blah blah, every 70 kilometers, and the mean time between failure and that equipment is not really up to what you need in a production environment yet. So because we are looking at mechanism of trying to do synchronization without using radio at all, but at the moment it's not really worth it.
Thank you very much,
Thank you.
Patrick.